I need to use my iPad, which I'm also using on Zoom. So it will be easier if I keep my video off, if people don't mind, just for today.
Yes, sir.
Just give me a minute. You guys can discuss. I'll be back now.
Yeah. You guys can continue. I have to submit my assignment.
Which assignment, Chetan?
Extra activity stats, my brother.
Guys, if you all are busy, you guys can continue with linear algebra 75, and we can always do the applications from next time onwards. Maybe even also many people are not around today, right? So once we start applications, we need, I think that will be a mode where I would expect many students to follow, because all the training you have had so far will issue out an action there.
Understood, sir.
You guys want to continue linear algebra 75?
I think we can continue, sir. We've finished till 23 questions. I was hoping that we.
Okay, so you can do that. I'll also give you as a puzzle what I want to discuss today.
Understood.
Right? Okay. Let me try switching on my video. Okay. So remember the Excel sheet I gave you? Can you tell me what's in sheet 1, sheet 2, sheet 3, sheet 4?
So there was synthetic data set in sheet 1, sheet 2, sheet 3, where each of the rows corresponded to a patient and each of the columns corresponded to a particular test that the patient had undergone. And you had asked us to observe that if we could represent the last column with some linear combination of the first 10 in one sheet 2. And for the sheet 3, you had asked us to observe that can we drop some columns in sheet 3 to, and still get the last column?
Okay. In the last sheet, can someone share the screen?
Yes, sir.
Go to the last sheet. What's this extra activity? Chernoff bounds, is it?
Yes, sir.
Oh, that's a wonderful idea.
I was going through that, sir. I had my deadline today, so I was just trying to link the activity. I've completed it, but haven't linked it to website.
Okay, good. So go to a random entry there in the last sheet. This is not the last. This is not sheet 1, sheet 2, sheet 3, sheet 4.
Chetan, were you able to verify the solutions that we did?
Yeah, I was.
Okay.
So these were the sheet 1, sheet 2, and sheet 3.
Okay. Okay, now in sheet 3, okay, can you share this with everyone?
Yes, sir. Guys, you can make a copy of this spreadsheet since it's you only.
Yeah. Even you cannot change it, no? Data mantra, even I have restricted you to share, right, Chetan?
Yes, sir.
Okay. So in sheet 3, delete a random entry.
Okay.
Okay.
You want me to delete an entry or the column?
Yeah. Stop sharing your screen, delete a random entry, and share your screen and show us the deleted entry. Entry, one cell only.
One entire row, you mean?
Cell, one cell entry.
One cell from any column.
Yeah. All of you do it for your respective cells, respective sheets. Okay. What is that entry? Is the question. Okay. First question. Okay, can we do some fun exercise today? All of you, do you have your cell phone next to you?
Yes, sir.
Can you all show me your, wait a moment, let me switch to gallery mode. Once again. Yeah, let me finish this and then move to the cell phone exercise. You have this entry in what, I10, what is that? I13.
I13.
Okay, I13 entry, what is it? Can you say? Okay, is the question. All right, you can stop sharing the screen. All of you understood the question. Go to sheet 3, delete a random entry and find out the value there. How will you find that out? Okay, first question. Second question, all of you show me your cell phone. Okay, take a high resolution picture of yours right now. Can you? Nice lighting. Nice lighting. Ensure that the lighting is perfect.
Actually, my selfie camera isn't working.
Oh no, you guys can take any direction. Maybe in fact, it's better if you don't take a selfie version. If you take the, because generally the selfie camera is low on resolution compared to the. Okay, Nishan is doing it the perfect way with the studio setup. Okay, send these files to Chetan. Chetan, you create a folder of these pictures. Are you people okay sharing? I mean, is a yeah. If you people don't mind, only share it. We need 2 or 3 pictures. Or you keep the pictures with you. Don't worry. Okay. Convert this picture to grayscale image. Delete a pixel and find out the value of the pixel using linear algebra. Is the question clear?
Yes, sir.
Exactly what we did with the Excel sheet. It's going to be so much fun. You're taking your own picture and finding out 1 pixel. And what we will look at is how do you find many pixels. एक pixel का solve करते हैं पहले. सर शर्लॉक होम्स बनेंगे हम बाद में. अब बस स्कूल में जो चॉकलेट को चुराता है उसको पकड़ेंगे. बाद में मर्डर कैसे सॉल्व करेंगे. ठीक है.
Guys, you'll have to send me your high resolution photos if you want to share.
Yeah,
In
yeah.
doc.
I have already WhatsApped you.
Yeah, share it in doc.
No, not WhatsApp. Yeah, seriously, that doc
Okay.
exactly. So otherwise, WhatsApp reduces the resolution.
Yeah.
Okay, guys, the point is this. The reason why I want you all to send your pictures is some pictures are linear algebra friendly. Some pictures are not. You will observe that. Hey, Bharat, wonderful to see you. Bharat is my childhood friend. I'm seeing him for after a long time. Okay. Yeah, guys, go ahead, take a picture. And some pictures are linear algebra friendly, some pictures are not. We will see why and how. All right. Remove 1 pixel and find out what's in that pixel. Do not worry. Do not break your head much about doing it properly. We're going to put all our linear algebra lessons in use. Please note, we started from module 1 and went like this. Now we will slowly go back and then sort of sweep this direction multiple times. Right, this is one such exercise. Now Chetan is tempted to leave his activity and then get involved in this activity. That was my challenge. As a teacher, I wanted to distract him from doing his homework and come here and do this work. How will we proceed? Any idea?
So first of all, I'm thinking how to delete those pixels. That's what I'm.
Delete that pixel. No, take it as a matrix.
Mhm.
First of all, convert the. Oh, okay. By the way, I forgot to tell you. Convert this image to grayscale image. Okay, with the maximum intensity that is possible. What is intensity? Can someone explain us the basics of image analytics, image analysis, image processing, whatever you call it? What's an image? Maria or Ankit, if you people have undergone a course in image processing, you can explain it to us. Anurag, Dubey, Nishan, anyone? That's the basics. It's not a big deal. By the way, how many of you have Git Copilot? Raise your hand. Nishan has Git Copilot. Okay. Ankit doesn't have.
No, sir.
Chetan has? No?
No, sir, I don't.
Chetan, ask for it, you will get it immediately. What you should do is create a GitHub ID using your IITM email ID.
So I did that, and they were checking my location. So my location is not near IIT Madras, so they weren't
Then you
allowed.
can always write to them and tell them that time, yeah, there's an online degree program, etc., etc.
Okay, I'll try it. That's all. So intensity.
Or put some of your Python files there on your Git repository, keep it open. You needn't be a student. The idea is you do charity to make use of that Git facility. You keep it open for Git to analyze, Copilot to analyze your data, and you will have it free of cost.
Understood. Guys,
I'm sorry, I'm in front of my iPad. I cannot type and show you anything, at least not easily. And I'm not comfortable using anything else apart from my personal programming setup. So you don't have it on my iPad. So you guys should be independent. Open the image, use either OpenCV or image PIL, Python image library. And figure this out slowly. Shri Vinay, Atharva, if they were there, it would have been easier. Are they around? Can someone find out if they're around? Or Shri, what's his name? What's his name? That BTech student who is very active?
Sriram.
Shriram only, is it?
Yes, sir.
Yeah, maybe you can ask one of them to come online.
Yeah.
Help us out. By the way, all of you should get used to programming, because from now onwards there'll be a lot of programming. And these days, programming, you need not know anything. It's all. I like the Copilot based teaching or learning or doing stuff. I mean, programming is all gone, in my humble opinion. It's good if you know how to use Copilot. Of course, it doesn't work. You should be able to debug it.
So Vinay is joining in 2 minutes.
Vinay is joining. Wonderful. Very good. Okay, now let's discuss theoretically how can we handle this? One pixel is gone. How will you reconstruct it? So by the way, I'm going to introduce what we'll be discussing for the next few days. Of course, linear algebra here and there. I'll be doing that. But then we will be understanding how data reconstruction works, how prediction systems work, how recommender systems work, how did Netflix become $1 billion industry? Is basically this problem. The basic idea is just this. How you use it is different. It has different applications, but the basic idea is this one. And I may, depending upon your linear algebra prowess, introduce Kalman filters. That's a very powerful technique used from ages. There will be no astronomy if you don't understand Kalman filters. It will be of great interest to all of you. Especially maybe Anurag, because he likes astrophysics. So when a missile moves, let's see it at a very, very high level. Missile is a point moving in 3D, correct? Do you think it moves in the right direction as expected? Your car doesn't move in the right direction as expected. Does your car move straight? You should keep it straight. Remember, I discussed it in the first few weeks of our discussion that you hold the steering and keep moving left, right. It's numerical algorithm that you're using to keep the car straight. You snake around the road. When you realize it's going towards left, you go towards right. When you realize it's going towards right, you move towards left. Correct? That's a beautiful numerical algorithm that you do to stay on the straight line. You don't stay on the straight line. You snake around with a very small radius of curvature of your snake. Smaller it is, better it is for you, at least for people on the road. If you keep moving like this on the road, then you're prone to accidents. Right? So, Kalman filter tells you how to filter out noise of a moving missile. Okay. An idea best explained using applications and best illustrated using linear algebra. We'll do that. For that, you guys should get some linear algebra maturity. Whenever I talk about decompositions and matrix transformations and inverse matrix transformation, you should feel very comfortable. You should not go by basics. It's like, what is 7, 6 are? Remember, as kids, we would start with 7, 6 are 42. But then with time, you realize that 7, 6 is 42 immediately. So linear algebra should come like that. Okay. Okay. Sri Vinay came and we lost him. Sri Vinay. Okay. we want someone who can program. So maybe you can explain the problem to Sri Vinay and let's seek his help to solve this.
So we remember Vinay, we had that data set, synthetic data set with 3 sheets in that. Do you have that data set? Let me share the link once again if you don't. Yeah, I've posted the link in the chat. So this was the data set. Okay. So I asked that take in sheet 3. Go to sheet 3. Obviously, you'll have to make a copy of it. You can't edit it. So just go to sheet 3 once you make the copy. Delete one entry from any of the columns. One cell, just one cell. Okay, delete that one entry from there and try to recreate that using linear algebra. And click a very high resolution photo of yourself using the back camera. I mean, I want you to do it.
So basically, let's finish this thread. That G6 needs to be predicted now.
Yep.
Yeah, now with the camera, you can close the screen.
So go ahead, click a high resolution photo of yourself with the back camera of the phone. Convert that to grayscale. Delete a pixel. Try to recreate that.
That's what we're gonna do. Okay. So we're trying to find this. I mean, we're trying to predict what the value was here. Is that what we're trying to do?
Yep.
Yes.
Okay. So what do you want me to do it through image? So that's what you want
Yeah.
to do.
First, yeah. Let's try it out with the image. I just want to learn how we delete a pixel from the image.
Just access the image's 1 pixel value and make it 0, right?
Yeah.
Like
So
it's lost its
how do we do that?
value.
How do we do that? Because I've never done that. So
Okay.
even
Okay. We can take. Can we just take image from? What is that?
probably
Image?
yours.
We have to
Nice.
take our image, na? Our own
No, we
image.
all have generated image. That's part of the experiment where we want to see which image is going to be a linear algebra exercise friendly. So we're going to do this for all images.
Okay.
Maybe you can crop the image to a resolution that's common across all the images.
Let me send you some sample images, Vinay.
Okay.
Can you
Sure.
take a look at your WhatsApp?
Discord will be better.
Oh, you want me to share them on Discord? Okay, let me do it. Discord. Then- Okay, no, I don't think. Okay, Discord compresses the photo.
Mm-hmm.
Let me send it to WhatsApp
Mhm.
as a doc. It won't compress it. Maybe for a second you can stop sharing your screen.
I've taken a photo of myself as well. Yeah.
Yeah, please do. Please do.
Srivinay, use your phone and use the back camera.
Yeah.
I believe that's an iPhone, right?
Yeah.
Yeah, use the back camera.
Back camera. Okay. I can't see on this camera, so is it? All right. Cool.
Convert that to grayscale now. Wasn't the angle perfect?
No, I'm not. I don't know why it's not clicking. Maybe this just. Oh, my bad. It was in.
Selfie
It
mode.
was in the front camera. Yeah. Mhm. Yeah. So you want me to upload this image here, is it?
Yep.
Okay.
I just want to see how we handle. Oh, this one's mine.
Okay. For me to send it, I have to send it to myself. Or let me send it to you.
Oh yeah, yours. Mm.
Bye. How did you send it as a document? I'm not
Yeah,
really sure.
just click on the. There are options, right? Photos, docs. Go to
Yeah.
docs. Check that image. Also, one more thing. You're using Windows, right? And you click the
Yeah.
photo with your iPhone.
Yeah.
Won't work.
Yeah, exactly.
Extension. You'll have to change the extension of it, and only then you can use that in Windows.
Let me just try
But
to
then if you do that, then you'll get compression as well.
uh, do we want to keep it as a square matrix? Or do you want us to crop it in some way, sir, before we work on it?
The resolution, if it's better that if the resolutions is the same across all photos.
Okay,
What
that's
resolution?
okay. Maybe we can crop it. We can crop it. Keep the resolution of the or the size of the matrix is constant.
Let me just check. So what resolution are you using for each image?
Can you check what on an average what's the resolution for the images? I
Mhm.
think mine was let me check.
I think mine is 1200, 1600.
We are resizing it. Okay.
No,
Mine,
I didn't resize it yet.
mine is 4,000 by 3,000. Are you reducing the quality as well?
No, I'm not trying to reduce anything. So you want me to reduce it to?
Let's just only reduce the size of it. Keep the quality as 100.
Yeah.
So yeah, maybe 1200 and 1600 would be fine, I guess.
What is the difference between JPEG and JPG? Does it matter?
I think yes, they do.
Reading will be done now in both the cases. Just
Yeah.
made any format.
Yeah, so this can
Keeping
stay
in the
like this.
Python code, it doesn't make much of a difference.
Yeah, so this is fine. So now let me download the rest, right?
That's already in Green Screen. You just have to crop it.
Okay. Have to crop it. Because 1212 is to 16, 4 is to 3, right?
I don't know, but for Windows, I always find Paint the most convenient thing.
Even I was thinking about using, like, I think if you use Paint, it would be.
Okay. Let me just. I don't know how to select. Okay, never mind. Okay, I'm not good at all this editing card, so maybe
Like, if you want, I can do it. If you send me the
Yeah.
images.
what do we want to do? We want to make all the images grayscale and okay.
If it is, yeah.
Vinay,
Yes.
instead of this, just
Me,
make a
I'm not
folder in
also.
Google Drive and share with Maria.
Mhm.
That will be
I'm also
clear.
not such a pro, but I think I can. Yeah, like, fine.
You use Photoshop before, Maria.
You know, I've done it using Paint. I think Paint is not that difficult.
Oh no. Paint, okay.
No, Paint recessing is the most
So
easiest in Paint.
okay.
Ketan, can you give me your ID?
UDAI VWR .990@gmail.com.
I think you can only. Oh,
Yeah, perfect.
Can you add the photos there?
Yeah, will do.
we need a code to convert it to grayscale too, right? Using some library like OpenCV, I guess.
Yeah,
That's
Or-
just
grayscale, okay.
Or like, is that part something you can use some online tool that just converts it?
Guys, it's going to be very easy. Where is the problem?
Like the resolution of the images are different, sir. So
Yeah, no, you should take raw image.
Okay.
So
What is it?
take your HEIC format, Sri Vinay.
How do I do
And
it?
no, maybe Atharva is around. Atharva, are you free?
Yes, sir. Yes, sir.
Why don't you use Copilot and then try to
Okay,
see?
sir.
Maybe Sri Vinay, you can explain to Atharva what we're doing.
So should we send the photos in raw format, sir?
you just
Yeah. All of you should send in raw format if possible. I don't know whether your photo permits that or not. iPhone definitely does. Maybe we can try it on Sri Vinay's image and then Try it on other images too.
How do I share it as a raw image? Anyone knows?
Pardon?
Yeah, how do I share it as a raw image?
Yeah, you'll have to use the doc, or if you can directly upload it to the drive, that can be, you can do that as well.
The only place that I've actually heard of raw images is in GitHub, like maybe I don't know how it's.
So what happens is when you click a photo on your camera, your photo does some processing on it. Every phone does, but in RAW,
Mm-mm.
it captures whatever the sensor captures. That's the photo. It's usually high resolution and unedited. So, and big in size, obviously.
Mm.
If I upload it, it gets uploaded as a JPG only. Is that fine?
I think it is specific to iOS, so
Mm.
maybe we couldn't do it.
Is it okay if we take a raw image from Google?
Mhm.
If that's okay. Or what are we planning to do actually?
We are planning to delete some of the pixels and try to fit certain values there and restore it. Starting from this point, we will scale it to multiple pixels.
Okay, I've uploaded on that group, but
Have you given me the edited access when you, okay, yeah,
Yeah.
you did, you did. Okay. Oh,
you want me to upload it as a grayscale?
no, so if you do grayscale from the very beginning, it will compress it. Okay. Guys, if you can click the photo in raw format, can you click in the raw format and send me the photograph? Just raw, without editing.
What do you have to do after converting it to grayscale?
Delete a pixel
then recreate that
oh.
pixel.
Atharva, convert this image as a matrix first and make any
Okay.
random entry there 0.
Do you have the image with you, Atharva?
I'll try on a JPEG. I'll convert it into raw format.
No, if you okay. So the thing is, raw format is unedited. So once you have that in JPEG, your phone
Hmm.
processes it. The data is lost. You're actually trying to upscale it again, which won't happen.
No, but
Only the extension will change. So when you click the photo in raw format, it
Hmm.
preserves that data.
no, but what like if we begin from .jpeg image and then
Mhm.
delete a pixel and then recreate that pixel, I don't think that should like matter.
I don't know. I mean, it's just the resolution difference between JPEG and RAW. That's it. Otherwise, it's not.
The image I have shared does not have any filter, so this should suffice for the row.
I've shared two images that are in RAW format on that Google. So
Yeah,
they're
share that folder with Atharva also.
yeah. Let me share the link. Atharva, tell me your email ID.
Um, I'll put it in the chat.
Yeah, send me the. Okay, you deleted it.
Yeah, I'm sorry. I'm making a typo again and again.
Okay, this. Take your time, Atharva. Take your time.
Yeah, this is correct.
Are you sure? You can check it once again. I don't want
Yes, yes,
to.
yes. This is correct.
Yeah, you should have the access. Can you take a look at it? If you
Yeah,
have.
just a second.
No. Vinay's image is already compressed. It's 2.4 MB. If you take a look at the image that I have uploaded, it's I think around 22, 23 MB. It's unedited.
Okay, so the .dng file, right?
Yep. .dng. Both are in raw format.
Yeah.
What happened?
There is some stupid people who keep turning off the MCVs.
It's. I mean, you're in the college, right?
Yeah.
So,
I mean, I don't even know them who they are.
oh,
The turn
You
of the
have
par.
you have some fun in college. Enjoy this.
Yeah, yeah.
So they are
Enjoy.
they're cutting off the par, right?
Yeah, yeah.
My goodness.
Okay, I have this. I have one of the images now.
Okay. Okay, now you are in grayscale.
I'll just turn off my video. It is very scary to look at me.
No, it's fine. It's fine, Atharva.
Okay. I'll be back in just a second. I'll turn it.
Chetan, how to take raw image in
Okay, so you,
Android?
I don't know if every phone has this option or not, but where you select your options of how to, in what format you want your images, or say portrait mode, photo, video, you have those options, right? In those
Mhm.
options, there must be some pro mode or raw mode. Okay, pro, yeah, or raw. In
Pro, yes, Pro. Start screen.
okay, so yeah, so
I have Pro mode.
yeah, so I was saying that if you have Pro mode, go to that.
Mhm.
Select in the top somewhere you must have option of JPEG, JPG. If you have the option to select the format.
So it is WB Auto, F Auto, S Auto, ISO Auto, and EV0.
Pardon?
The options are WB Auto, F Auto, S Auto, ISO Auto, and EV0.
Can you send me the screenshot, Nishan? I'm not able to understand what you're saying.
See, I've sent you. Check it. Mhm.
No, not this. So this is just the white balance, focus, and ISO
Okay.
settings. These are those settings. In the go to that top bar. I think those top. You see the bars right on the
Mhm.
top side.
Then
Click on that, and
settings.
if you have some option to change the format in which you want the photographs.
I'm afraid there is no option for format. The options are anti-banding, customize, camera modes, no, feature layout, nothing here, color sound, no, focus and shoot.
Don't we just need one image? So if yours was raw, then we can try that out, right? Like you can send
Yeah,
us one.
for once we need one, but sir asked to get more images to see which of them are compatible.
Okay, okay.
Maria, were you able to convert them on the same pixel scales?
With the what?
Sorry.
Were you able to convert all the images in the same pixels, same amount of pixels?
Same resolution, okay.
Actually, I didn't get the images. Like, I didn't do anything. Like,
Oh, you okay? Let me send you the.
I think Atharva is back. I guess he knows. Like, yeah, or you can send it to me. I'll try it out.
Yeah, we can like crop the image in NumPy in Python also.
That will be great.
How would you actually get it as a metrics of
You should do it on
band?
Python only because we want the exact resolution. The resolution should be the same across all the images. So should the intensity values
Hmm.
per pixel.
Okay, in that case, Vinay, can you just get the, or Athava, you were doing that, right? So you
Yeah,
just
I'll share my screen.
all the issues resolved. Okay, maybe not.
Uh, what do I do after this? Like we store
Yeah,
the image as an NumPy array.
yeah. Then convert convert the resolution to a constant resolution. I mean, we want every image to have that same resolution. So I think
Okay.
let me check.
Atharva, instead of this, you can go like uh, take image all the images present in the current folder, make
Okay.
them all grayscale, make them of same intensity, say by a value, make all the images of same
Oh.
resolution, and save them
Do we
by
want every image to have the same intensity as well?
yeah.
Okay.
Okay, so I'll have to download the rest of the photo. I think. Yeah.
Yeah, yeah. Atharva, are you there?
Yeah, yeah.
Okay.
Yeah, I have the two raw images in this now. Are you sharing something? I can't see. Okay, just a minute. I'll reshare it. Okay, yeah. I think when I switch my tab, it automatically pauses it. Is it visible now?
No, not yet.
Just a second. It's not even stopping me.
You have a network issue. Kind of wanted to clarify, by intensity, we mean the amount of pixels in a unit area, right? So that's what he means when he says the intensity has to be same, right?
That's
By definition,
that's PPI. That's not the intensity. PPI is a bit
Intensity is
different.
usually the brightness of a
Yes,
picture,
correct.
right?
And
Or
brightness or the
intensity.
grayscale level, that should be
So
intensity.
usually intensity ranges between 0 and 255, right? And that happens to be for RGB. So usually you get 3 different values for a particular pixel. You have 3.
Okay, that's the same as intensity, okay.
Mhm. So when you all said that you'll have the same
Ganga,
intensity.
stop it.
Yeah, then the same intensity.
Sorry, guys, my mic is not muted. Chetan, in such situations, please mute my mic. I was scolding my pet who is, yelling to come inside.
Yes, sir, will do.
Yeah. So when you say same intensity values, then you'd end up getting the same image, right? It's like saying
Or is it a
That's why
sum
also I
the
thought.
pixel values? Like I saw something related to that.
no,
Like
the range of intensity values, if they're different, it's hard to work with 2 different images, right? So maybe keeping them in the same range makes sense. Usually 0 to 255 or depending on grayscale image or forcibly stop
possibly.
screen share. Maybe if I try to share my screen, are you all able to see my screen?
I
Yeah, yeah.
think maybe
Yeah, it's
maybe
visible.
the
Yes.
host or the co-host can do that, like forcibly stop someone from screen share.
But I
No,
can't even
but
see that
if
he's
the request is again the same, then
No,
cannot.
what do you want? What do you want? Who wants to share the screen?
Atharva is not
Atharva.
able to stop his screen share.
But his screen share is off.
Yeah, in his side. So maybe there's some issue.
I think it's
Okay.
internet issues because his video is
Atharva,
also pausing.
can you leave
Yeah,
the
yeah.
meet and can you rejoin maybe?
Yeah, I'll do that.
Linear intensity, yeah. If that's what intensity means, yeah.
But like looking into the question, if we delete a pixel randomly, what is going to happen is so what will that particular pixel be affected by?
Yeah. So, correct. So, you guys are going in the right direction. Question is simple. The pixel can be anything, right? But you see, I see a matrix of Sudarshan, Chetan, Ankit, Anurag, Bharat, Nishant, Srivinay. I'll just remove one person here. Let's say Nishant and Atharva. Let me remove Nishant here. I don't know who that person was. Can someone predict who that person was? I may not be able to predict the name, but I probably know his qualification. With a very, very high probability, he's a data science enthusiast. With equally good probability, he's a BS student from IITM because our coder's eye is dominated by them. So much that they dominate us. Right, so most of our discussions are being dominated by IITM BS students. So all these information we can use and then say that with a very high probability Nishan is this person. We can even say that this person is male, given that we only have Maria around. Apart from that, all of you are boys, right? So these are all the parameter involved in judging a person depends on the others in the matrix. But here in this matrix, you all have nothing to do with your rows and columns, but in an image, a row has correlated pixel intensity values. A column has correlated intensity values. In the column, you don't have intensity values coming uniformly at random. Can someone tell me what is intensity value? I'm using a jargon here. Are you following what I'm saying? Shivani wants to explain.
Intensity is something like the level of brightness, like how much white or how much black the particular pixel is.
Black is 0, white is 255, or maybe 1023, whatever, right?
So what we store in the NumPy array is basically the intensity.
That's it.
Okay.
Right, it's a matrix, n cross n matrix, without loss of generality, we'll assume that to be a square matrix. The image is a square matrix, right? Of course, it can be mostly, it's always rectangular, but we take it as square for ease of our computation. So assume it's a square matrix, and in each value is between 0 and 1023. Okay, or it can even, you can go up to 1 million values if your monitor can permit. Grayscale values, depending upon if white is n, black is 0, you can stretch n to be anything and put anything in between. Your whatever light emitting diode should have that capability. Your pixel should have that capability. That's a pixel basically. Pixel is a dimmable light, although a very, very small one. Okay. So these pixels, based on whether let me just observe, let's say, Ankit. You see his rows and columns of the image. In a row, are you wearing light green shirt or green yellowish shirt, Ankit?
Light yellow, sir.
Yellow, sir.
Light yellow. Okay, so you see if one pixel is missing in that row, it's yellow. Or if it's missing in the middle, maybe it's his neck, roughly gray. I mean, light yellow would be slightly on the dark grayish side, if I'm not wrong. And his skin tone will be slightly less grayish than his shirt. I don't know, we should see. Right? So I know if something goes missing, I'll look at the neighborhood and then figure out. Or I have the entire row, entire column, or many such columns and many such rows. Linear algebra has come to you. Now it's for you to invite him home and then give him the required guestly treatment and then talk to him and then figure out how to find out what the pixel is. Trust me, you can find this out with a very high probability, meaning that accuracy will be very high, provided the matrix is very big. What do you mean matrix is very big?
The resolution raw picture.
Resolution is big. Yeah, on to you people.
I'm sending you another.
So, Srivina, you're going in the right direction. Think like that in first principles and then figure out. Yeah, Chitan, go on.
Okay, Anurag, that's not a raw photo. You'll have to send me that on my WhatsApp as doc. Discord, WhatsApp, any sort of messenger you use, it compresses your photograph automatically. I'm putting my WhatsApp contact in the chat. You can take a look at that.
Okay.
Anything else
Are
I
all
should
the
add in
images in
this?
.dng format?
Yeah. Only two. I have only two images. and they both are .dng format.
Yeah, try printing also, no? That array, so that the last
I
one.
think, okay.
DNG is the digital negative. So sort of like how we have negatives for photos, right? We can get the photo with that negative. So DNG is the extension for POW. If you have some way to change the format of the photo within the camera app itself to DNG or RAW, try doing that.
Atharva, since when have you been using Vim?
Uh, from the start of the semester. So I think from August.
Okay, and now you are this proficient, right?
Yeah,
Okay.
yeah. Atharva will also have some scary stories to share about his instructor. That will be for some other day. Atharva, you really should handle a session on all the scary stories from our course that your instructor taught.
Yeah.
Anyway, so long story short, I forced Vim on all of them, and out of 225 students, only Atharva picked it up. The other 224 students hated Vim like anything.
I was wondering how come he's so proficient, and he looks young in that regard.
Otherwise, controlling himself not to blush.
There is some problem again.
So what is the prompt that you have used, Atharva? Can you show me once?
Yeah.
Open the images in the current directory, the images. Do one thing, just use one image. Okay. Convert
Okay.
that to raw, convert that to grayscale format, and then convert that to a NumPy matrix. That's all.
It's saying cannot handle image with photometric interpretation.
Is it does it have to do with the extension or the image, like .dmg?
No
No, I
idea.
doubt that. I doubt that. I mean, .dng is the digital negative extension, so a
Okay.
lot of softwares are compatible with that.
Let's ask ChatGPT.
Yes, gonna say, yeah. That or something in Stack Overflow.
Oh,
If you
custom
have
instructions. Yeah.
Use Microsoft as there is ChatGPT 4.2.
go to Copilot, Atharva, do you have Copilot? Not
Yeah.
the Get Copilot. I'm not talking about Get Copilot. I'm talking about. Are you on Linux?
Yeah, I'm on Linux.
Okay. Do you have Edge in your system?
No.
Okay, you
So
don't
once
have
again,
Edge.
what's the issue, Atharva? Can you show me?
Yes, sir. Cannot handle image with photometric interpretation is equal to 32803 something.
Okay, wait. Show me the code.
Yeah.
DNG का DNG format. एक minute. Okay. Okay, try a JPG itself to begin with, and then try a DNG later.
Okay.
Can you show me once again what was the error, Atharva?
Yeah.
320.
No, that
Okay,
sounds
so-
like a very weird error inside the some CPP file that is used by OpenCV.
I think, sir, it cannot access DNG. I was googling.
Yeah,
there's
yeah,
some-
that's why I said JPEG try करो देखते हैं. Linux seamlessly converts any format to any format, so you can simply use the convert command if I'm not wrong. Just say convert space image underscore convert whatever आपका image name
No, okay.
image name. I hope it's installed. Let's see. Ketan.jpg. Enter.
Mhm.
No. I'll just download this.
Yeah, click on it and then download. Yeah, click on it on GIMP or something. Anyways, open that image. Yeah. Just use some JPEG file from the internet.
Yeah,
आपका ही कुछ होगा है ना?
Yes, sir.
You change the entire code. Maybe do it from the beginning.
Yeah.
That will be easy. D capital G. नहीं अथवा पूरा yeah correct.
Yeah.
JPEG था या JPG था जो भी है. JPEG. Okay. Ankit, what do you use for front lighting?
So it's a normal room light.
Acha.
Hmm.
From the top, right? I can see the
Yeah.
shadow also there. Yeah, I see.
Yes, sir.
Is it a incandescent light or fluorescent?
I don't know. I'm not at my home today.
Okay. Acha.
I need to check that.
Mhm.
Okay, done. We have that numpy array.
Very good. So, see, what we want is a huge image. That's why I said high resolution. If you make it 256 cross 256, it becomes a small matrix.
Yeah.
Right?
So maybe 1024.
No,
Make it
take a
1200
very
by
high resolution
1600.
picture. Very high resolution picture.
Okay, I'll download it.
High resolution grayscale image. ही ले लो. Take the mountain. Oh, wait. I'll tell you the exact one that's probably here. Come down. Take the woman one there. Woman's face, high resolution. No, not this one. No.
Can you go to Shutterstock?
Yes, that one. Grayscale image. Just click. How big is the image? Just see.
So very
How do
small.
I
It's very
see?
small. It's very small. It's 400
I think
something. Go to Shutterstock.
I
Atharva.
think we can get from Unsplash, right?
Yeah, Unsplash, Shutterstock.
All of you try and yeah.
You go to Grayscale. Put a filter. Put a filter for the size.
Yeah. Grayscale. Generally, these are like
Sort by,
really
sort by,
big image.
sort by. Is there an option for resolution?
All of these are generally very big images, so I think it will not be a problem. I'll just find a square one. if
Take the
possible.
dog. Come to the dog.
Yeah.
White and black. I think this might help. Yeah, definitely store this. And take that. Okay, definitely
I
store
think we'll
this.
get a raw file also, original file.
That's what we want.
Yeah.
And do one thing, don't convert it to square. That's not required.
Okay.
So which means you will get the, yeah. Thingy. Check the resolution at the end. Print the dimension of the matrix.
Think you're only printing the
Image shape does not work because this is a PIL format. Convert it to a NumPy matrix. It's not image array ka shape.
Yeah.
Array shape.
Right.
What are you using to split Atharva? Tmux, is it?
Tmux. Yeah. Tmux.
Okay.
It is 4032 cross 30.
Wonderful. So open the, create another matrix, replicate this matrix. Guys, let's do it on your own image later. Maybe we'll do it on this image right now. It could be passed by reference equivalent. Maybe it's a pointer. New image is a pointer. Like, is it really replicating it properly? Are you sure?
No,
I think it's
so
dot copy. Image array dot copy.
Dot copy
How?
or just
duplicate the matrix, Liko. Duplicate the matrix. Yeah. Find a random value of I and j from pick a random pixel. Pick a pixel randomly. A random pixel. Pick a pixel, find a pixel randomly, and output the row and column in the NumPy array as well as the value. Very good. That's all. Yeah.
I think we'll have to import random also. Yeah.
It's using the np.random, so it's using the
Achha,
NumPy.
okay. Oh, right.
It's okay.
Yeah. Yeah. There's no harm. Yeah.
It's not outputting the value of the.
No, what you do is find a pixel randomly and output the row and column in the NumPy array, full stop. And after, in the last line, you say output the value of the matrix at row and column, which by the way you can output it directly. नहीं इसको हटाओ, इस लाइन को ही हटाओ. नहीं 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 redo. Okay. Do not write anything about as well as the value hataओ. NumPy array full stop. Stop. Next, come at the end after the last line. After the last line, you type print the pixel value. Last line. Yes. Here you type. It says change the pixel value to 0. How does it know what you're doing? Okay, interesting. Okay, now change the pixel value to 0. Predict the pixel value लिख दो. The pixel value.
No.
Pixel
It is
value.
just printing.
It is some other. Okay. Now this is where you stop, and I think people should manually code this. How will you solve this problem right now?
Yeah.
So change the pixel value to 0. Before that, you are printing. Okay, can you execute this?
Yeah.
Two 33 था है ना?
We changed 230 to 0.
Okay, now again redo it. ये क्या 0 to 255 है क्या values?
Yes, sir. I think matrix values would be between 0 to 255.
Did you change it? Where have you changed it? I don't think you changed it. It's by default that.
No, we are picking up random values. So every value
entries in the matrix. Why is it 0 to 255? Have you specified that somewhere, or it's picking it up by default?
No, by default.
By default, in the image open mrdog.jpg convert L. Right?
Yeah, I think when you make it to grayscale, it goes to grayscale 0 to 255.
By default. Okay.
I'll check that one.
You can check and then tell us if we can increase it. Okay, good. So yes, guys, on to you all. Discuss now. Use all your linear algebra ideas to tell us what is this missing value. Why will your idea work? Tell me that. All of you very actively discuss. Next 10 minutes should be a lot of discussion. The next 10 minutes, your ceiling should fall. The discussion should be so high on intensity. Go ahead. You can basically stop the screen share and share us the CPP, the .py file with everyone, Atharva.
Yes.
as well as maybe a good idea would be to git commit it somewhere and share us the link or whatever you're comfortable with, Google Drive or
Yeah,
whatever.
yeah, sure. Yeah, sure. I'll put it on GitHub.
Wonderful. Yes, guys, on to you all. Go ahead. देखो अब हम जितना भी लीना जो पढ़ेंगे, if we don't apply it, it's of no use. Whatever we are studying in row space, column space, null space, बोल के we can go on and on, right? So where is all these things coming together? Feel free to make your share of mistakes. Go by first principles.
Okay. So, Atharva, can you just give us a brief of what we have done till this point? We have some new people in the meet as well. So maybe just
Yeah, so we have just taken a grayscale image, a big grayscale image from Google, from Unsplash. We opened the image, we converted that image into grayscale, and then we store that image as a NumPy array basically. And we have just created one copy of that image, and we chose a random pixel in that image, and we made it 0. We basically deleted that pixel.
now we are trying to recreate that pixel.
Yeah, now I want to bring it to original image.
Okay. Okay, let me just share that synthetic data as well. That
First thing I want to like kind of understand is that this is like a smaller part of the bigger question we were trying to solve for all these days, right? Initially, we were trying to find an entire row of values or like column of values, right? We were trying to predict an entire column of values, right? Given the other columns.
I think if we I mean, this was the intuition that I was getting as well. That
One second. Srivinay, good. Go ahead. Yes, we were trying to do the entire row or
Yeah.
entire column. Now, what are we doing?
Now the
For a
column
single
is just for one particular value. So it's like we know what the values are for other rows, and it's only this one particular value that you have to find out. So it's like there are hundreds of equations. 99 of them are solved, and you just have to solve that one equation kind of
Okay.
thing, right? It's
Okay,
like
more.
only one variable you have to like tune to understand what that value would be.
Yeah. Will you figure out that row or will you figure out that column? Maybe both, right?
Yeah. We can, since we know that column can be expressed as a linear combination of the rest in a good approximation, right? That's what we've been
Will the
seeing.
column be a good approximation or a row be a good approximation? Or will it be
More
exactly the
rows.
same?
It'll be the same, I feel.
Are you sure? What
If it's a square
quote,
matrix.
which chapter, which verse of Gita or Bible or Quran or whatever of our linear algebra, which says this? We also have our share of verses and chapters in linear algebra, right?
Yeah.
No, the rank of the matrix is going to be full here, as you know.
Sir, idea was that if a column is a linear combination of rest of the columns, then we'll certainly have a row which was linear combination of rest of the rows.
Okay.
Yeah.
See, in real world data set, you can never have a row as a linear combination of other rows.
Yeah.
Correct? Can you all now? I would like to see this very high intensity, batting and fielding happening. Someone should hit the ball and someone should jump and catch the ball. I mean, defend, offend. Go ahead. You have learned so much of linear algebra. You should put them to practice. How many people? Shivanai going in the right direction. Chetan going in the right direction. Ankit going in the right direction. Go ahead.
Yeah, Chetan, you wanted to say something?
yeah, I mean, this is what I wanted to say, that I was getting the idea of that data set we had. There we were trying to come up with the linear combination for the 11th column, right? Here we have almost all the data. If we can come up with the so what linear combination gives me that particular column, or say that particular row. Since I only have one value missing in that since I have only one value missing in that row or a particular column, if I can get the value for the rest of the rows or for that particular column, that what is the linear combination value for that? I
In
think we can get that.
in a greater context, if we see, our rows are just the like number of observation. So mostly we focus on columns. That we should that's why, because we also did the same thing for the data set in Excel sheet,
Oh,
no?
no. In
Google
the
sheet.
image, it doesn't matter, right? There, the data was carrying some meaning. So the rows were
Yeah.
entries of per patient, right? There we
Yeah.
there was so here the image, it's an image, right? What's the difference between the column and the row of the image?
Yeah, in image it does not matter. We can put either of the two approaches. Either we go first from the column or
Yeah.
first from the row.
Yeah. That's what I was thinking. That it doesn't matter for at least for the image.
I had a very like nice thought. I don't know how I really came upon it, but say I try to take a random value for that pixel, right? Say I'm just randomly choosing a number between 0 and 255. I kind of realize this one thing, right? See, the rest of the columns itself would form some space somewhere, right? It could be some space somewhere. But for that, so if we are able to, let's say we are approximating it, right? We don't know the real pixel value at all for that column, right? We don't know that pixel value for that one particular element, right? But if we try to approximate it, saying that say that column is a linear combination of the rest of the columns, right? So what I'm trying to do is look at the point on that space which is there created by the rest of the columns and find which is the closest to that point. And there'll be only one value for that pixel which would actually lie on that space, unless it is creating a new if it is creating a new direction. I don't know if I'm actually thinking of this right. See, if for a particular
but,
value of y, it will lie on that space. For a different value of, say that value is x, right? For a particular value of x, it will lie on that space. For a different value of x, it won't lie on the space. That's how I think about it. So I will try to find that x which lies on that space.
Can you repeat that?
Projection.
Can you repeat that?
Yeah, so it's like saying
essentially, let me frame it in different words.
Yeah.
What essentially he's saying is, like, the image is made up of multiple columns. Let's assume whatever this pixel that we have deleted it, that might be in the same column space of rest of the columns, means as a linear combination of rest of the columns. And in that way, that there are two major possibility for this pixel value. Either that is inside this space that is spanned by rest of the columns, or it is outside the span. So he's considering these two possibilities for the pixel value.
Really, can you look at the chart?
Yeah, that's what I wanted to talk about. Projection, right? So see, I don't even know what I'm projecting. Like I'm trying to predict some value where that value can be anything between 0 and 255, right? So when I think about, say I have 10 columns and 11th column, third row is missing. That is the X value we're trying to find, right? If I think of the 11th column as some linear combination of the first 10, I can express it as some linear combination of the first 10, then I can definitely find one value for that X. But if it happens that it is not, I will approximate it with that X, is what I'm saying.
Now consider this problem with a different perspective. You guys remember that projection thing that we did a few days back when we were projecting our clusters to a space and then to a line, then to I hat, J hat, and K hat. Ultimately, what you did is when we were plugging 0, what essentially it was decreasing is it was projecting. So can we see this problem as in that matter itself, like when we are putting a particular value 0 at some column in the an entry a column, essentially what we are doing is we are projecting it. It was in some space initially, Now we have projected into some lower space, means but now we want to restore it. Then there are multiple values if you want to restore it. Like for the same thing, na, like if this were our access system and they were clusters, if we use a projection matrix on and projected the clusters on just xy plane, then they will be equidistant, but all the information in the third dimension will be lost. And if we try to reconstruct it, we cannot get the exact value, but can approximate it that it should be around this thing.
Good, Atharva.
Yeah, so first of all, my issue is that if we want to find the value of a pixel, why should a value of a pixel which is very far away from that pixel affect the value of that pixel? So basically what I'm saying is, why shouldn't we consider just a small area near that pixel and then try to relate it to that?
Yeah, that would be the first thing to do also. You're right. Because it will be affected by the ones closer to it the most, right?
Yeah. So first
So-
thing that comes
But
to
I
mind
can't-
is like maybe we can like find
How
an
can we connect it
average
to
of
something that we've learned? That's all I'm thinking about. How would I
So-
think of it in what we have learned?
Yeah, so essentially what Atharva's point is, instead of considering all the columns pictures, we just focus on area around it. But fixing it to our this current understanding, I don't know how we should link both these things.
Like,
Because
some-
idea of that we get that we should focus on the nearby thing through that Copilot itself.
yeah, like one thing I want to ask is that we know that it's being affected by the neighborhood points, but like how much of a range of neighborhood would we actually consider? Isn't that something like, because like a lot of points, I mean, would affect like something that's very close to it would affect it more than points that are like further away, right?
yeah,
Yeah.
and I think it would also cause problems when we are on the boundary of something.
For images
Yeah,
we can
yeah,
definitely for images we can definitely consider the area around that missing pixel. But we cannot extend this idea to that data sets like the Google Sheet one.
Exactly. Yeah, that's the thing. How do
Yeah,
I?
yeah.
And also, in addition to that, how would you determine that area? That's another challenge in itself.
yeah.
Yeah,
How
yeah.
much close of like should we consider when we look at the like we know it's affected by the proximal values, but we don't know the range of the like how many sets of rows or columns we have to consider when we have to predict our missing value, right? We don't know that exactly.
Yeah. But how do we arrive to the fact that we should consider all the rows and columns?
Maybe
Because it is as likely like that pixel being correlated to a random pixel in some other column and other row is as likely as some random pixel in its neighborhood, right?
like something I thought of, like maybe like
I'm
uh
sorry, less likely. I'm sorry, less likely.
yeah, something I don't know if this is correct. Like something maybe you can think of it like in a probability sense, like maybe the one closest to it will have a certain weight that affects it more, and then when you go further away, like the weight of that point on predicting our missing value will be lesser, and as you
No,
move away, the weight like how much it contributes to the prediction would be lower.
Maria, but
Okay.
we should try to fix it in linear algebra context itself.
In the same
Yeah,
sense,
yeah, I
as
mean,
Ankit
yeah, it's
says, see, doesn't alpha, beta, gamma values tell you how much that other column actually affects your the column you're trying to predict? That's what your alpha, beta, gammas are, right? The
yeah,
constant.
so yeah, okay, so maybe we can assume to an extent that like how, like depending on the level of accuracy we want, we can actually take, like we can decide like how much proximal points we need to consider to determine our to predict the missing value, right? Because obviously the more further points we take, our accuracy would be higher, right? Because
What do you mean?
like see like it's like if I want to predict that missing value, the points close, like the pixel values close to that point would have a more effect on it than the ones that are further away, right? Because yeah, so even if you ignore even if you ignore the points that are further away or the pixel values that are further away, like
Error will
your
be less. Like it's like saying,
yeah
Algorithmically,
it's
how
like
will you
saying using
decide?
lesser.
yeah,
Yeah.
like your accuracy is directly correlated to the amount of like the proximity you take. So
Yeah,
the
let's
more
say
proximal values you take, the more your accuracy.
Algorithmically, how are you planning to decide that what is your optimal proximity?
Yeah, I think, see, when you try to show it as a linear combination of your other columns, I feel the columns which are closest to it will actually have the highest alpha values, beta values, gamma
Yeah,
values.
it
It will
will.
happen because of
The
natural,
nature
how
of
it
the
works
image.
itself. Yeah, the nature of the
Yeah.
image. It's more directed. See, it's more closer, right? Because the vectors are very close to each other. If you think of taking those two columns, like take this column pixel and this column pixel, they're very close to each other, even in their
See.
vector space, right? So
Yeah,
I
so
feel that.
like except the case where Atharva mentioned where you have something like a boundary, then we'll have an error. But most cases, like the only thing is that like the more accurate you want, the more amount of like
more columns
you
you'll
pick
take. Yeah.
columns further away you'll have to take. Yeah.
Yeah. So instead of so you're saying this could be one option, this could be one option, this could be one option, or taking the entire image to predict that one value is also an option, right?
Yeah, yeah.
No,
One more question.
consider this also. Like this is your image. You have removed this pixel. Now we have one option also. This like let's remove this row because this row is having a missing value, and removing this row and treat the image as single entity. Okay. Now for that column, let's find if it's linear combination of rest of the columns, and to what values it is linear combination of that. If we can get that, then that will give us a good approximation to find the missing pixel value.
This was actually the idea I was
Linear
thinking about.
Oh,
I,
no, I was thinking that like we tried something similar when we had to do the data set, right? Like we tried to find the last column as a combination of the other ones and it didn't work, right? Because when you have such a large amount of data,
See,
like we had
it
a
did
very
work. It did work. It did work. It's just that it was including the error as well, which was expected. You can see when you have this large data, do you think that you will get a nice value of coefficients that, okay, this is the coefficient that you're getting, and when you multiply it back and you're going to get the
I mean, at
the
least
value.
it should have been close, right? But our error was pretty high, right? That day.
I don't
Yeah,
know. I
but
mean,
that was around 200%.
yeah, so
Yeah,
I
yeah.
don't.
Like Rishabh pointed it out that day, right? Like
Yeah,
we
but we all tried it with different methods, right? We still got the same answer.
No, but we need to agree
Didn't
now
we?
that it cannot be like for the value
I mean, maybe
64,
the
it was going
underlying
340.
idea in all our methods was the same. That's why we got the like maybe the
Just a second. Yeah, go ahead, Atharva.
Yeah, so my question is would it be enough to consider the column in which we have the missing pixel? Is it enough to consider that column as a linear combination of the rest, or do we need to consider it as a linear combination of the rows also? Because if the image is varying from left to right, it is also varying from top to bottom, right?
So are you suggesting if we do it row wise, we might have a different estimate, but if we do it column wise, we might also
Can we
get a
try
different
it out?
estimate?
Can we try it out? See, just going by the intuition, we probably won't get the idea. Maybe we try
Yeah.
it out and see if it's actually the case, and then backtrack and see try to figure out the reasoning for that. Can we
Okay, sure.
can anyone do that? Just delete that whole row, figure out the linear combination that leads to that column, and then delete the whole column and I mean undo that deletion of row and delete the whole column and figure out the linear combination for the row. Atharva, can you do it on
Yeah,
there?
yeah, sure. Yeah, sure. I'll share my screen. But for some reason, it is a nightmare to stop screen share. I have to leave
Okay.
leave the meeting every time.
Yeah, that's why I asked if you had any network issues. Like,
No, network is fine, I guess.
might be some issues.
Okay.
I mean, when I saw that in what Copilot suggested, that seemed like a good method of approximation too, by taking the
Yeah.
average of the surroundings. Like, yeah, but even
But how do you
Yeah,
fit
that's
that?
one obvious way, right? Good.
mm,
But given that we have been learning linear algebra, can we try the linear algebra way? Maybe even try both ways and then see which one is more accurate in what context. In fact,
average
the linear
obviously
algebra way,
has an
I'll give you.
issue, like maybe like in case of outliers. So I guess when our image has a lot of boundary conditions, like what's the boundary of some closed image,
Okay,
I think there would be a bigger error when you
yeah,
do the
okay.
average.
Let me give you a nice intro here. So, what do you mean by third column is a linear combination of the first two columns?
It means that it lies in the span of rest of the two columns.
One way of seeing it. Other way of seeing it is
You can
third
get the third
column is the average of first and second column,
Yeah.
provided you take alpha and beta as 0.5 and 0.5.
Weighted average,
Yeah.
then on a general basis, yeah.
Is weighted average more powerful or non-weighted average more powerful?
Yes. Makes
Answer.
sense. A
Is
weighted
weighted
average.
average more powerful or non-weighted average more powerful?
weighted average.
With
Weighted,
weighted average, we can do
Okay,
multiple
first
things.
question. Second question. Do you think weighted average of the first two columns more powerful or okay. Is the weighted average of the previous two columns more powerful or the weighted average of the previous 100 columns more powerful?
Previous
400, yeah.
Previous. All
So what are we
of them.
doing here?
So, okay, so the last column, the most unrelated column would have a smaller weight by default.
Yeah.
And,
So
and a
whatever-
closer column would have higher.
So
whatever
more
it was
accuracy
suggesting, see the
means
neighborhood is what we are doing. Just that we are
Yeah.
giving less importance for the faraway pixels, but not zero importance.
Yeah.
Less importance.
Makes sense.
You see, linear algebra implementation here is basically averaging only. In a different sense. In a more powerful sense. Correct?
yeah.
Sir, but how are we sure that looking at rows is sufficient?
Look
Like,
at columns, look at rows, look at whatever you want.
So
Look at everything.
if we see like this weighted average thing for the column, it is fine for images and so. But if we see the same picture in this like Google Sheet question, then we cannot show that nearby columns will have more weight.
Yeah,
Depends on the
exactly. There,
nature of the data,
conceptually
right?
doesn't make sense. You are right. Conceptually doesn't make sense, while conceptually in an image it makes sense. It's in the nature of the data set, is what Maria is saying, right?
Yes, sir. Yeah, that's what I think because, yeah.
Correct. There, Ankit, you're absolutely right. There, the neighborhood has nothing to do with this side, while a column has something to do with the entry. Column is the marks of one person. Row is the different marks across the same subject, right? Who says in the image also this is not true? This is true in the image too.
Yeah.
Every row has some pattern, every column has some pattern, right? Okay, go ahead. Try your linear algebra methods to practice. Don't worry, I mean, it comes slowly. This is a warm-up exercise. So if you think someone is brighter than you, then you hit the reset button and then go slowly. But going slowly will teach you more than going fast. This is an excuse to learn more. This is not a intention to solve the question quickly. Okay, go ahead.
So if we have a rectangular image, we'll have suppose we have more number of columns than rows. So if we find a linear combination of rows, and we find a linear combination of columns, is it possible that we'll get a more accurate value if we take
Yeah,
the
I think
columns?
so. What? Let me correct me if I'm wrong. This is, I think, what I was suggesting, and I think Ankit was suggesting the same. That we have one missing entry, right? We have one missing entry in the entire data set. Why not drop that whole column? Okay, figure out the linear combination for that particular row. Okay, and do the same for column as well. Drop that entire row, figure out the linear combination that leads to that particular column, and estimate the value with those. Is this what you meant, Atharva?
Yeah, kind of.
Because what do you mean kind of?
Yeah,
Did you
I
mean
just wanted
something
to
else?
see.
Mhm.
I just wanted to see which one gives a better approximation.
Yeah, same.
Yeah. So maybe if we consider both, it would be even more accurate.
No, I mean, I don't know how we could consider both, but yeah, I mean, one by one we can see, and then let's see if we can somehow combine both as well.
Yeah, we can try that.
Yeah.
So
Just drop the first drop a column, that particular column, figure out the linear combination that leads to that leads to that particular row.
Actually, our matrix is going to be a full rank matrix, right? So,
Does it matter?
yeah, I don't think it matters. Like the previous, like the Google Sheets was also not a full rank matrix. It was
Right.
10 cross 10,000 something.
Hint, take a one low rank matrix and what? Add a small error factor. The matrix
it becomes a full rank. Okay, yeah.
By the way, images are always low rank matrices, but appearingly high rank, full rank rather.
I wanted to
You can compress it. And then, okay, that's the reason that day when we compressed it, we were still retaining that information. Are you writing something, Adhara?
No,
maybe yeah we can so I guess we kind of got into the idea that we'll have to take the combination of either the rows or the columns. But how do we figure out the weights that
What?
do we run like we figured out that like that one column or like that pixel value is
Hmm.
you can find that out by taking the proximal rows or columns, right? And you take the
I I don't
weighted average
understand
of
why.
the points that are closer to it,
I
right?
don't understand the reasoning for proximal columns. I don't understand that reasoning entirely. Because why okay, even if you're taking that idea of proximal columns, how are you going to determine which are those proximal columns?
Yeah,
Why not?
like
If you
yeah,
want,
but it's kind of logical in the sense that like if I take my eye, like the boy, like if you take just one point and the like one row and something a bit below would be very similar, right?
yeah,
So
I
when you want to,
understand, but how do algorithmically come up with that?
yeah, so the more further away, your weights would be lesser.
Well, I
The what
understand that.
contribute? Yeah, yeah.
You remember that whole contiguous subarray question we were doing? We were trying to figure out that okay, when do we drop the idea that okay, we won't find something further, right? Same we did with the columns. That how many columns we drop
Yeah,
to
like
get.
that depends on the amount of accuracy you want. Like if I
I
want a
want
95% accurate,
I want maximum accuracy. So that's why I'm saying that why even consider proximal columns? Why not consider the
Well,
entire thing?
yeah. So if you consider the entire thing, you'll get a 100% accurate thing. But obviously that would be computationally more difficult, right? So you take,
Yeah.
Atharva,
yeah,
Atharva, don't you think if we delete both this complete rows and both the column and rows, both the things, then it's tough to find the exact weight that the column or that row will hold. It's better that either we delete that row or that column,
No,
so
he's
that
not doing both at the same time. He's
yeah,
doing
I
one
am
by one.
just
okay,
yeah. So I wrote
we
right
delete it from
columns as
the
a linear
dropped
combination
row.
of other.
If you
Okay, no,
delete both,
that
then the whole thing is gone, right? You don't have
No, no,
any way to recover that.
I just gave it a name so that it could
okay,
understand what I mean by that dropped row and dropped column.
okay,
Yeah,
I'm just deleting one row and then expressing the column as a linear combination of other columns.
yeah, sure,
And then we'll find the coefficient and multiply it to the dropped row, which we deleted.
yeah.
was Chetan actually trying to say? Like you said something, right? Like you didn't understand the reason why we're taking the proximal points, or
I understand. I'm saying how to do that optimally. How many are you going to take? 100? 500? How many?
yeah. So
And how do you decide?
I
Okay,
like something I kind of think like this is the way I'm thinking. The more further away you take, it's like your accuracy would be higher, right? So depending on the level of accuracy you want, I think you can directly correlate like that to the amount of proximity you're taking. So if you're taking extremely just the extreme close, like the weighted
I
average
think
of just the extreme close values, you'll get a lesser accurate prediction than when you take further away. Like the more data you take, the more accurate your model would be.
okay. I think we can. I could be very wrong in this. Okay, this is just me trying to mash your idea with what we did earlier. So why not do one thing? Drop that column, figure out the linear combination that leads to that row using the eigenvectors and eigenvalues. Figure out which rows has the least eigenvalues. Drop them entirely. We don't need those. Then figure out okay, what is the value for that particular missing uh,
Even I thought about eigenvectors, but usually uh, we
what do
take,
they tell? See, what do they tell us? They tell us that where your majority of data is lying, right? That's what we need. When I was asking this question to you, that how do you determine that which are the what is that proximal area that you need, right? Uh, so that proximal area should have the highest impact on that particular value, right? That's what you meant. So I don't know. I could be very wrong. I feel that the if you are trying to figure out for that particular column, the columns the closest to that will have the highest eigenvalues. I don't
Usually,
know.
yeah, when we talk about the eigenvalues, like we talk about like the whole information, right? Like the whole image as an information, and you're saying that the maximum amount of information is retained in a particular direction.
Hmm.
But here, since we are trying to predict a missing value, like maybe we can think of it like
One
take
thing
a
is for
smaller
sure. Yeah, go ahead.
maybe like take some points, like take a smaller amount of the image and check out the eigenvector. No,
Okay, now
uh,
that see why I don't think that would be a great idea, because how would I know that those are the columns that have that already have the high eigenvalues? How do I know that? I have no idea.
like I can't correlate the idea that like obviously eigenvector, like the eigenvalues are the ones like
Oh, don't think of eigenvectors as something different. So what we did yesterday, we were trying to figure out the basis. You remember this discussion I was having with Nishant about eigenvectors being the basis. Why are we even considering that? What's the benefit of doing that, right? So they are linearly independent. They will give me the basis for the vector space, but at the same time, they give me additional information that my data is lying along those particular eigen vectors which have the highest eigenvalue, right?
yeah.
So
I guess the point I was trying to make is that uh the eigenvector of the entire data is the direction where maximum information about the whole data lies, right? But since we have to predict a random point in the metrics, like that direction might not be like the one with the largest eigenvalue might not be the direction that has some impact on this random point, right?
do you remember what we did when we were trying to figure out what was the value for that 11th
Atharva,
column?
it was
Yeah.
struggling at some bottleneck. Why don't you write it like that, multiplying both sides with the transpose of this matrix and make that a square?
No. There is a package like NumPy package, I think, which does that automatically. We don't have to do that.
Okay.
So I think
Exactly.
if we just change something here, it should do it.
Okay, so I was saying that you remember how we came up with that linear combination for the 11th vector? What did we do there?
The way I remembered it, like I'm not exactly sure this is what we did, like because because the columns only, like there wasn't any other error, like we assumed that it depended just on the columns. We tried to do a baseline fit, right? And try to determine the coefficients or the weights for
What was
each of
that
the column.
baseline fit? What was that baseline fit?
What was that baseline
Why
fit?
did we even think of finding out the eigenvectors and eigenvalues? Didn't it mean that I'm trying to find out the basis for that matrix? That once I found the basis, I know that every vector that I have is lying on that in that vector space, right? In the span of that basis. So I can use any vectors in that vector space to figure out the other vector. That what is the linear combination that leads to that vector, that missing.
Okay. So yeah, because your eigenvectors are also a basis. Yeah, that's correct. That's
I mean,
something
I
we
could be
discussed.
very wrong in this. I have no idea. I'm just shooting the arrows in the dark of what I am.
Yeah, something eigenvectors would be the basis, but uh,
They give me what are those minimum columns, or say what are those minimum vectors that give me the entire vector space that consists of all the vectors I have. So if I have that minimum number of independent vectors, or say that basis, I can get the linear combination of for any of those vectors, right? That's what we are trying to do here as well. But need not we need not we don't even need the see why I think the whole idea of eigenvectors and eigenvalues came when we were figuring out how to drop some columns, right?
Yeah.
Here, if we want the maximum accuracy, we don't want to drop any column. So we can use the entire data to figure out what linear combination of that leads to the particular row or say column. Yeah, in case we want to reduce the computation, yeah, we can figure out the eigenvectors and eigenvalues and drop those since they are not contributing much. Obviously, I'll have some reduction in the image quality.
Actually, I mean, yeah, I mean, considering eigenvectors makes sense in the in the way that we don't have any other numerical measure about our weights, right? Because
Right.
yeah.
That's what I was trying to see. I mean, we know that intensity, but how do I measure that intensity? The only thing that came to my head was the eigenvalues, that how much they're
Maybe,
contributing.
yeah, rather than taking the eigenvectors for the whole data, maybe we have to
One thing is for
suppose
sure
your
that
point, suppose your missing point is in that direction where you have very less information. Like we know that some information is going to be there, right? So suppose a random point that we eliminated, which we're trying to predict, is in that direction, it's in that direction of error or that very small information, then it doesn't make sense to take
drop it, drop any dimension. Is that what you mean?
no to use the eigenvector corresponding to the largest eigenvalue, right? Because our missing point and that direction of
No, no,
highest eigenvalue don't have that much of a
we
correlation, right?
we no no we see we when we came when we discussed the idea of eigenvalues and eigenvectors, we did that because we wanted to drop some data. We wanted to reduce the dimension of the data, right? Here, the thing that you're saying, that if it lies in the direction where very less data lies, it doesn't even make sense for me to drop any dimension, because the moment I drop the dimensions, I have more error. I can't.
Here, I think we're not using the the only way I can correlate this to the idea of eigenvectors is that we know that we need to have some weight associated with the proximal values, and the only numerical way you can actually consider that is yeah, you can do this for a region, yeah.
But my
Java, one consideration here, like
Yeah.
when we are referring to ith and jth row now, it should not get any updated. And should we clarify a few points after line 21 from the line 21 itself in the comments?
Okay.
Like for the line 20, if we
It's just
check,
on. Yeah.
like in the line 1,
Bottom.
below one, below
Yeah.
one, like you're saying that multiply the row I with the coefficients, and what actually we wanted to find was the particular pixel that was at the
Yeah.
row and jth column. So we should specify that itself, no?
Okay. So,
Can you explain what you're doing in the code? Like I didn't
Yeah,
actually pay that much.
the idea of this is we know that the pixel has ith row and jth column. What
Mhm.
essentially we are doing, we are deleting the complete ith row.
Okay.
And for the element that are remaining in the jth column, we are considering it, we're trying to find it as a linear combination of rest of the columns.
Hmm.
After we find this weights, this linear
Then
combination
multiply
thing,
that with the row.
then we multiply this coefficient with rest of the elements of row and calculate the that ith and jth entry.
Okay. Yeah. I'll think about it. I didn't quite get everything. I didn't get the logic of doing that. Yeah. You delete the row. You delete the row. Then you
You
take
take the
the.
linear, you see, you have your data set, right? You have your data set. You have one entry missing somewhere. What we
Yeah.
are proposing is delete that entire row. Delete that entire row from your data set. Figure out what leads to the to what linear combination leads to that particular column where that entry lied. Okay. Once you have that linear combination, just multiply that value with the every value in the deleted row to figure out what that missing entry was. And do the same for column as well. Once delete the whole column, figure out what linear combination leads to that particular row, and then multiply that to the deleted column and figure out what that deleted entry was. So Devaswamy sir is here. I will just give a brief of what we are doing today, sir. We have a image that is a very high resolution grayscale image. We deleted one pixel from that. We are trying to come up with that particular value that we deleted using our existing knowledge of linear algebra.
You are trying it from either row side or column side.
Yeah, right. So what we thought that if we delete that entire row of the missing value, and figure out what linear combination leads to that column. Using that value, we can regenerate that entry with some error, of course. And you can do the same with by deleting the entire column and taking what linear combination leads to that entire row. We are not sure if it's going to work out, so Atharva is trying to write a code for it, and we'll see if it.
And the reason why you're deleting is because you want to save space. Is that the motivation?
No, if I don't delete it, will the function give me the linear combination since there is data missing in the matrix?
What we are missing any random pixel and we are trying to find that random pixel. Now we had a few ideas, but we thought that this idea might work. So now we are testing it. And do you have another idea that how we can recover the deleted pixel value for a grayscale image?
So essentially, it's like a data corruption, right? So let's say for some reason we lost some. So there's a matrix n cross n or n cross m, and we randomly lost mij. The idea is to guess what we lost, right? It's like a data recovery.
Right.
Right, something like that, right? Okay.
That's how, I mean, that's what we did. That's how Sir started as well. Sir took that spreadsheet data, that 3 sheets where we had patient data, and he asked us to delete one entry, and he asked us to figure out what that entry is. So it is like a data recovery.
Yeah, got it. So maybe exam students answers for all subjects are entered, but one graded sheet is missing. So now
Right.
kind of impute, looking at either the subject marks or other students who are similar to him.
Right.
All right.
I mean, the other idea that that some of us, I mean, some of the people gave was that take the weighted average of nearest pixels for of the deleted pixel. So uh, I couldn't think of the algorithm for that. That how do we figure out which nearest pixels should we take? What should be that area that we should be concerned with? So we didn't go that way. So
Yeah, you could always take a 3x3 neighborhood or a 5x5 neighborhood, and you will come to an approximate answer, right?
mhm.
But obviously, this I can't really think of this in terms of linear algebra. I think that is where, or maybe it's not exactly related to that.
So only one pixel is deleted.
Yeah,
Not
only
the-
one.
Not the entire row, not the column, right?
No.
Okay.
Hmm.
Interesting. So think of an image, even if one pixel gets deleted, we can intuitively, without knowing too much of math, right? Fundamental first principle, look around all the neighboring pixels, right? So let's say any pixel that are like, how many neighbors are there? Like, 3 on the top, 2 on the side, and 3 on the bottom, right? So I mean, assuming it's in a two-dimensional space, what if we take average of all these 8?
Yeah, but this I can't think of this in terms of our data set that we have, right? For the image, it might work.
So
For image, how do you come up with
RGB,
that
right?
area, sir?
What is
You
it?
can take anything. You can
No,
take-
For
that,
image, Mhm.
that thing is easy now. Just we have to mention the ranges for which we have to pick the values. Taking a subpart in a matrix is easy, but till now what we have seen is we don't have anything like this in linear algebra. From pure linear algebra perspective, the only choice that we have that I can think of is this weight thing only, the linear combination thing.
Yeah, right.
So
See,
the taking average is also kind of linear algebra. What is it essentially? So when you're taking simple average of previous 8 points, I'm basically multiplying all the points by 1 by 8
1 by 8, yeah.
and then summing it up. So essentially I have a
Not linear combination.
vector containing 1 by 8 and then multiplying it. That's another way to look at it, right? Isn't it?
Yeah, I can see that it works for the image, but I can't see it happening for the data that we have, right? That's the
What is the
thing.
data you have? Is it like numbers?
No, the
Yeah.
patients and the patients
It's
with the
RGB, right? The grayscale 0 to 256.
For
No,
image, that's the data, but the other data we had was the patient data. We that had 10,000 rows for each patient and 11 columns for each test they are underwent.
Yeah. There it doesn't make sense to take the neighboring values, right?
Okay,
Yeah.
so here we can apply, what we can do is, if we take real life, right? First of all, a row is basically a patient, right? So first I want to do is I want to ignore that column. So let's say there are 10 columns, right? I believe that's a 10 columns. I group all our patients into homogeneous groups. Okay, we can't use anything, only linear algebra, right? I don't know.
Yeah,
what-
like I also thought of this idea of like grouping it into some like yeah, like I just like it wasn't entirely my idea, but yeah, like maybe like instead of we can actually like in an image, obviously you'll have a lot of objects, right? So with object like one particular object, like now in case of my image, my face would be one object and my hair would be one object, right? Because you can consider that as a group of data. and you can try to approximate that this new pixel, which group it actually belongs to, and figure it out. Like, yeah.
Otherwise, we can think of this one, right? Let's say we have 10,000 patients. One column, one IJ is missing, right? Row I and column J is missing, right? So let's say the fifth, I mean, out of 10 variables, the fifth one is missing, right? So if I express my fifth column is my dependent variable, let's call it column vector, label vector Y, as a function of all other columns, and I train it on all the rows except that one that is missing, right?
I
The
think that's
highest
what
row.
we're trying to do now too,
Yeah,
right? Like,
yeah.
it's similar. It's kind of similar. We're trying to express it as a linear combination of the others, and
I think that will
find.
work. That will actually work. In fact, we can discuss the math behind the regression, right?
The example that David sir actually took, like, in that case, like, actually, you can't consider the, like, when you have a lot of patients as data, I think that would be different to the data as in an image, right? That's also something we need to consider, because I mean, the amount of effect that, yeah, that's something that one patient would have on, like, something, just because in a hospital, if I'm the first person coming, I have a disease, the next person coming won't have that much effect on the disease that I have, right? But in the case of images, like, the proximal value has a more impact, so that example might not be the ideal case to consider.
This is what we discussed last night as well, right? This is what Nishan was suggesting, and we said it doesn't make sense for us to do that.
Now consider this point. A few days back, we were seeing image as a sum of M plus C matrices. Yeah.
Yeah, right.
The column of M we can recover if it's linear combination of rest of the column. But the particular error value, that E, I, J, we cannot recover. One thing we have to add. Like if
how many rows and columns we have in this data set?
It was around Shad, 2000 some Shad.
4,000 something and 3,000 something.
Okay.
Sir wanted us to take a large image so that we can do this.
Yeah, so 4,000 rows and 10 columns.
3,000 columns.
3,000 columns.
It's an image, right?
Oh. Yeah. Yeah. So we have to do dimension reduction because we actually discussed in linear algebra, right? In order to solve a system of linear equations, let's say there are basically 4,000 equations and 3,000 unknown parameters, right? Essentially, that's what it is, right? Right? So it's a large dimension. And what we learned from our discussions, sorry, I kind of joined in between. There is a lot of missing values for me also, right? But the point is, when I got a matrix, which is 4,000 by 3,000, we all understand that the real data lies only in a small subset, that n by n and d cross d we discussed the other day.
Yeah,
right?
I like we could do dimensionality reduction, but something that, like, we are actually removing a random point in the data, right? So obviously in when we do dimensionality reduction, we assume that like most of the information is along that one dimension. So if the missing point that we take is actually along that error direction, then how can we actually apply dimensionality reduction to come up with an accurate thing?
Maybe what we should think is, if we decompose the matrix into what we remember that decomposition, we talked about that Q lambda Q transpose, right? I think that was discussed by Sir. I missed that session. So we should see each point as a linear combination of these eigenvalues and eigenvectors, right?
Yeah.
So whatever is missing, as well as non-missing. All data points are linear combination of these eigenvalues and eigenvectors, right? So in that sense, once we get the equivalent eigenvalue and eigenvector for the matrix, then finding the actual value for the missing data point should be. So in other words,
Yeah, that's what I like. Yeah, so I mean, that to me doesn't like taking the direction of the eigenvector doesn't seem logical, because since a point is random, we can't say that the eigenvector, like, it could be in the direction where you don't have that much information too, right? So then taking the eigenvector direction doesn't seem logical to me. Like, it could be any random point, right? So, or like maybe I think I have a few gaps, like in the way in the way we actually
Yeah, go ahead.
in the
So
way we actually like do dimensionality reduction for an image. Like, I think I like
Are we trying to reduce the image? That's my question here.
I
I
mean,
don't
that was
think
the
we are trying to
suggestion,
do
right?
it. I don't think we are trying to do that. We are trying to get a as close possible value for that missing value, right? That to the original. So dimensionality reduction we do because we have large data and we don't want to deal with all of that data, right? So and then we come up with eigenvectors, eigenvalues to figure out, okay, which are the columns that I can drop, which are the vectors I can drop and still retain my information. Here we are trying to guess the closest possible value to the original one. So I mean, until and unless we are trying to minimize the computation, it doesn't make sense for me to drop the data.
see, Chetan, we also talked about, remember that A transpose A and AA transpose discussion,
Right.
So in order to solve these, let's say, find a solution, let's say, right? If you're doing linear algebra, we are inverting a matrix. So what will be the dimension here? If you're taking n cross m, so at least we are talking about a 3000 by 3000 or a 4000 cross 4000 matrix, right? And matrix inversion is an order n cube. We know matrix multiplication, inversion. So that means it's going to be huge task, right? And a lot of these vectors are going to be correlated, right? So how do we get that? So because we know there is correlation means dependency, instead of solving a complex problem, if the only way dimension reduction will help, instead of dealing with the 3000 by 3000, we'll probably deal with something smaller, and that smaller will not get rid of the important information in the matrix. Once we get that, then for any random point, we can probably put that point through the transformation to get the predicted value or reconstructed value.
But I have a doubt in this. But if we do dimensionality reduction, we would achieve lossy reduction, right? But in this case, I think we don't want the lossy reduction. We just
Another
want
thing,
to
I
recover
think
this. Then we should.
Atharva, I'll add something to that. Were you there the day we reduced that size of that, not the size, we compressed that grayscale image? Were you there that day?
By what method? I have done this, but I don't.
I
I
mean,
think I've done this alone.
See, I don't remember the method as well. It was Sir who was doing that.
Did we do it using SVD? Like,
I think, yeah.
we split it into three matrices. One and the middle one is diagonal matrix, and the smaller one we make zero.
Yeah, we did that. Yeah, we did that.
Yeah. So that is lossy reduction, right?
Yeah. So what we observed there was that even after a lot of reduction, our image wasn't changing much. So that means that in images we have a lot of possibility for dimensionality reduction. That even if we do that, we are not going to get a lot of error. So we will get somewhere in that ballpark. So we will get the value in somewhere in the ballpark of the original one,
Hmm.
even after
Yeah,
the
yeah,
dimensionality reduction.
that makes sense, but it would still be considered as a lossy reduction, right?
Correct,
We
correct,
wouldn't have
correct.
our original
Like, I
values.
think if you do, like, it's always in a real world scenario better to do a dimensionality reduction. But
Mhm.
since we are here trying to predict something we don't know, when we do it, I think the accuracy at which we can predict the missing information would be less.
Yeah.
No, I think this should work.
See, dimension reduction is not the answer. It is just going to help you
Correct.
get the answer faster without affecting the quality of your result
A
significantly.
lot. Oh, yeah.
That's the whole idea, right? We know that y minus y hat, there is that reconstruction error will always be there. Whether you do it in 3000 or 100 dimension, right? So yeah, I mean, okay. So what? Who is doing it? Atharva, right? So you're trying to.
Yeah.
Yes,
So I am getting this one problem here. It is showing incompatible dimensions when I use least squares function in this NumPy thing.
Incompatible. So maybe the dimension of.
Let me just check. Okay.
Let's choose the print the dimension of the any kind of matrix multiplication. Maybe they are not compatible. The order can be where we are doing that.
Which function were you using?
LSTSQ, least squares. Lineage.lstsq.
Okay. So, okay. I mean, if you want to use really do a regression, you can use sklearn, scikit-learn, and then import a linear model and create an object and dot fit. So give the x matrix and y vector. It will give you the coefficients.
I'm sorry.
So if you want to use, if you are allowed to use scikit-learn, there is a linear model package, sub package inside that, which will help us to do basically a regression. Because here we are saying y is equal to beta x plus e error, right? We're trying to estimate the beta vector, the coefficients.
Let's try this once.
Yeah, try this. If this works, that's great. Siribina left. He was having headache.
Yeah.
Left, yeah. So yesterday was the assignment due date, right? So busy with that.
I had a due date today as well, sir. I have. I mean, it hasn't passed yet.
Yeah, takes a while to do these assignments.
And now,
Athava, you have a bad connection, I guess. Okay, I can only see Bharat moving, so I know my connection is okay. Okay, now I can see the Vishnu Saraswati. Okay, yeah, Tharva's connection is bad. Focusing on that idea of that weighted average, can anyone just tell me how do we even approach that weighted direction approach? I mean, we are trying to do this approach. Obviously, we'll see if it's going to work out or not. The other one by dropping the row and the or the column. But mm, how do we go about that weighted average approach? What would be the
We
algorithm?
know, yeah, we know that like the closer one should have higher weights, but we don't know by how we are numerically measure that.
Mm.
That thing
No,
will
so think
essentially
from
come
a-
up when we are looking at the coefficient values now.
So typically, how do you do it? You give it to a kid, right? You draw a bunch of points, you give the coordinate value. 1 point, it's on pencil, you erase it. I mean, see, most of the things should be logical, right? Should be easy to understand, right?
Right.
A guy who even doesn't understand linear algebra, what would he or she, standard 6 student do, right? They look at the curve, right? If it is a line, then you can take a simple average. Very simple, straightforward. If it is a curve, then you kind of try to fit a quadratic or a cubic fit through those 3 or 4 points, right? So similarly, because we can assume it's a linear, then its life is easy. You can do like a simple average. It's essentially what we do in machine learning, MLF, is you have a curve, function is a curve, and you're trying to approximate through linear approximation, right? Otherwise, if you want to be more accurate, then don't fit a line, fit a quadratic point. Or if you think that's still under fitting, then you can assume cubic, right? So that's logically what people would do, right? So now the question is, this is MIJ. You can do it on row I or column J directions. Or if you think you are going to take a two-dimensional view, then there are 8 neighbors. Or if you take a row view or a column view, right? So I think it makes sense. It's a matrix, two-dimensional object. So we should somehow focus on neighbors means across the rows as well as columns. But the assumption is it's patients, right? Let's understand statistics. Are these two patients, are they related or unrelated, right? Right. What does it I mean, image is very clear. There's a dependency when we go from column to column, row to row. But if you're talking about patient data from a hospital, patient ID 1326 has nothing to do with ID 1327. Right? There's no distribution unless we sort it and do some kind of ordering of these. Some food for thought, like image versus real life data, right? It's image has that continuity. You can smooth and you can do here in case of patients, patient 1 could be having, like somebody said, a heart attack, and the person is seeing, like a cardiologist. The second person is having audio issues, hearing issues, then that's the record. And then we have monitored each person's blood pressure, whatever, right? Sugar, whatever, right?
So in that real life data where we have the patient's data, does it make sense for me to even try and figure out that which which patient is linear combination of other patients, or does it make more sense for me to figure out which column that
So now you're thinking, right? That's why I was. So you can clearly see patients are not going to be correlated because unless they're from a similar group, right? If you're talking a bunch of heart patient, maybe they're related, but all the heart patient could be scattered through randomly, right? So
correct.
Now if you talk about statistics 1, right? Are these rows, they definitely are not identically distributed. Are they independent? Probably yes.
Probably yes.
Identical, right? They're independent. Now, when we go to the columns, like blood pressure, or people with high blood pressure probably will have more heart attack, or people with more weightage probably would have more blood pressure. So you would see naturally the
There's a
column
correlation in that,
right, compared to the rows. So that is what intuitively we would see.
Correct.
That if you want to work on estimation, we should start with the column space.
Correct.
Right.
And it even makes sense to try and figure out what linear combination of those columns lead to some other column, in case you want to drop some columns to make it easier for you to process the data as well.
Yeah. So that means we have to express column J as a linear combination of all of the columns.
Interestingly, sir, it doesn't matter in when we have image. So there we knew that what our constraint was, that we have had patience. But in a case of an image, my column and rows are pretty much the same. It doesn't there is no constraint on that okay, you can't. So here I have a constraint that each row is the patient data. There they are all pixels containing some value. So whatever I can do with a column, I can also do that with the row.
Correct.
Atharva, is it working? Are you sharing the screen?
No. I'll start again.
I'm still thinking about it. I mean, obviously we are using this approach of dropping a row or a column to get the linear combination for the that particular row or column. I'm still, my mind is still stuck at that weighted average method that Bharat was mentioning. But do you have any algorithm to come up with that?
See, so this is actually a very interesting comment you're making, right? When you're talking about taking average of neighborhood,
Right.
you are essentially doing local smoothing. So essentially, if now big distribution, you're not worried about the generic distribution of the variable, but rather focusing on a specific locality of each of those, right? So if you have a joint distribution of 5 variables, you don't care about the entire domains.
Distribution.
You are basically looking at where the point is missing, where is the hole, and you are only looking at the local neighborhood, right? So essentially you are doing that. But in case of regression, what you're trying to do is you're trying to understand the overall relationship across the entire domain, right? So that's basically trying to figure out the generic relationship between these columns and then trying to use that learning and apply it for the missing row. And there are different mathematical algorithms for that, right? So what you're talking about is imputation versus regression, basically the technical term. What we call that is missing value is called imputation. You're trying to impute what the value for that missing value is. So there is left, I see is logged in.
I mean, so wouldn't it be, so when we are saying that when we are taking the average of the, say, nearby points, the proximal points, aren't we interpolating the values? Wouldn't it be interpolation?
It is interpolating because it is within the domain. Extrapolation is when you take it outside. So yes, it is interpolation. Yes.
Is there an algorithm to interpolate? So can we try that algorithm for this problem?
I don't know what we are allowed. I mean, the context matters. So when Sir asked the question, no,
he just okay. He only mentioned that use your existing knowledge of linear algebra. So I guess not correct.
Yeah. So we should not probably step ahead of ourselves. So otherwise, we'll get biased, right? So we should think from a very simplistic fundamental principle what you have done so far. Okay, it's ChatGPT. Yeah, scikit-learn, yeah, should be.
I mean, it makes sense. If there was no way using our basic linear algebra knowledge, you wouldn't have asked us this question. So I'm pretty sure there is
And by the way, since sklearn is being implemented, it actually has imputer objects. Maybe we are jumping the gun here, where you can impute. So typically missing value is a very normal phenomenon in real life, because there is maybe the data was captured in a piece of paper and data entry operator made an error and it was out of range, so hence it's a missing value, right? So these are pretty common. So as a data scientist, first thing you have to do is called data pre-processing. So before when you build a model, you have to make sure any kind of missing values are treated, and you impute the values before you go ahead with your regression or any kind of other machine learning models.
Yes, it would
Okay,
specifically
so
be, yeah.
does this require like an older version of NumPy? I think it is saying this is too new for it.
So, okay, you can, okay, so you are doing scikit-learn 3.2.0 and it is not
Yeah,
aligned.
it says
SciPy.
Okay, I'll tell you people a very straightforward first principles way of solving it. Okay, so what you do is keep this particular ijth entry is missing, right? Put that into the last column. Okay, your ijth. Can someone open a whiteboard and then try writing what I'm going to say? Okay, so
Just a moment.
sure. Someone screen sharing?
Maria is doing so.
Okay.
She's probably connecting with a graphics tablet.
Okay, so take 5x5 matrix and take the second row, third column in it as the missing entry.
5x5.
5
Sorry,
cross
sir,
5.
can you just
5 cross
random entries?
No, just put dots maybe. I'm only saying what you should do. You should take the missing entry, that column, and put that column at the end. This is just for explanation purposes. You need not do this physically, right? So yeah, 1, 2, 3, 4, 5, 25 dots, easier on the mind, and highlight the third
Just
row.
leave one of them. Leave one of them. Erase one of them.
No, which is third row, second column.
Yeah.
Okay, yeah, no, third row, second column.
Yeah, third row, second
Make it
column.
that's it, circle it. Now what you do is take the entire column flush it to the rightmost side. Basically make the second column the fifth column.
Second column, the fifth. Okay.
Yeah, make second column
So
the fifth.
should I draw it again?
No, wait, all of you
Just
understood,
remove the
right?
circle
I
and
wanted
move it
you
to
all to
the
understand it. That's all.
move it to the
Okay. Yeah, I can just rub it. Yeah.
Yeah, we have moved it there. Now, can you see the last column as a linear combination of the previous columns, which is simply a simultaneous equation? That's all.
Yeah, that's what.
So this is what we were trying to.
Correct. You are trying to do. Yes,
Yeah.
this is what you people are discussing. But why would you do this? What is the order of the universe that declares this to be a valid method? Where does the physics of this spring from? How do we even know that we have the right to call this a simultaneous equation? Right? It's a simple image. Where is an image? Where is a simultaneous equation? Food for thought.
Okay, now I could be very wrong in this. I'm not sure, but this is something that I was discussing with Rag today as well. That uh, we had that ax equals to b, right? We had a as the function, x as the input, and b equals to the output. There
That is
we
that Chetan, that is how that is one of the many ways of seeing this problem. Hamiltonian equation is seen as a function acting on an unknown vector and giving a known vector b. Okay, but right now the very model, I mean, can you people question the model? Is this model, does it even make sense? What does it translate to in real world terms?
So, I mean, we are discussing if it is patient's data, rows are patients and columns are different measurements we have taken on patient. Maybe the data entry operator forgot to input the blood pressure. Let's say the missing dot is blood pressure of the patient, and for the patient number 3, we missed recording the blood pressure, right? That's a real life situation. Now we are trying to estimate the blood pressure of third patient using all information available to us.
Yeah, even there, philosophically speaking, you look at blood pressure as a parameter that can be estimated as a linear combination of other parameters.
Right.
If you consider the column picture, if you consider the row picture, it is like you estimate one person as a linear combination of other people.
Yeah. So which is kind of not a good because patients are more likely to be independent compared to the columns. In fact, we did this that. Yes.
Correct. So whatever is longer, you take that more, consider that more than whatever that is shorter.
Right.
But you see, the number of patients are actually more in number than the number of parameters.
Correct.
Yes.
Right? It probably is easier for us to check, given a patient and his blood pressure being missing, you find out what is this person a linear combination of. Okay, it is perfectly fine to see it this way. And then you find out he is a linear combination of 1 million people the following way. So his blood pressure will be a linear combination of these many people. In fact, that is the entire experiment. It's a brilliant observation that you will see that row picture or column picture will give you the exact same answer here.
I guess that's what we were trying to verify as well.
Yeah, if you simply take least squares. Least square is, this doesn't have a solution, take the closest point. Or if it does have a solution, fit that solution and see what that solution is. Of course, this will not have a solution because it is not full rank, right?
Yes.
Estimate solution, the
estimate. What you now do is, what did Maria do? She has shared the picture, right?
Yeah,
now
right.
move that whatever gray dot to the last row, last column. Estimate the last column as a linear combination of the first 4 columns. Okay. By considering only the 4 cross 5 matrix. In this, you consider only 4 cross 5 matrix. By the way, 5 cross 5 is misleading because it need not be a square matrix. Okay.
Right.
Right. Now, take the first 4 rows and the 5 columns there and estimate the 5th column as a linear combination of the first 4 columns. And plug in that coefficient to the last row. How many of you understood what I said? Yeah, so if you, maybe Devasmith can drive the discussion right now. That's all is the idea. Try looking at this way. And see now this was the column picture. See also the row picture. See the ijth entry as you look at the last row as linear combination of the first few rows. Okay, and figure out in the last column what are those coefficients that will give you the last element, which is n cross nth element. That's all. Row picture, column picture, dono dekhiye and solve it. This is all easy to do. This is just like your M1, M2, M3, M4 problem solving that you would have done in your engineering days. But then, why does it work? What is the English equivalent of it? Why do we take the liberty of modeling it like a simultaneous equation? Right? That's a bigger philosophical question, which again has some nice roots in math and physics. We'll discuss that. But at the time being, figure out the row way of seeing it, the column way of seeing it, and figure out the answer, and also try to understand why this works for an image. And once this is done, the next level would be, I didn't mean to complicate it, but I'm just finishing the syllabus, so to speak. Look at the SVD of this. And why are we looking at the SVD? Is basically, it's like the super duper average.
It's still drop off.
Yeah, yeah, it says internet connection most probably.
Maybe by mistake, yeah. Yeah. So ultimately, yeah, all roads would lead to Rome.
Mhm.
Guys, sorry, got disconnected. So I was at the fag end of my conclusion. I hope this is clear. If I can confirm that at least one or two of you have understood it, I will retire and you people can discuss.
So what just
Devasmit, you have understood, right?
So what just happened? What you said while you are disconnected is actually the problem you're trying to solve.
Yeah, but correct. So when I got disconnected, I was about to say good night. That is independent of what I stated. So technically, at least. Okay, guys, have fun. Take care.
Have
You
a
can
good
try.
night, sir. You go ahead, Atharva.
It's also a possibility in an image that, like, if you have an image and someone just scribbled on it, then you can't predict the scribble based, like all the things that we sort of discussed, right? Like, or you made, like, some person made a random dot on the image. You can't predict, and our random image, like, the missing value is that random dot, just like Sir's good night, like it was really abrupt, right? You can't predict that properly, can we? But in most cases that
Obviously,
won't-
that was one question, right? That was one question. That is every photo. Can you do that whole operation of linear algebra on every photo? Is that possible? That was one of the
Yeah.
questions that Sir initially posed, right? So this, I guess, the case you pose lies in one of those groups where you cannot do this. Yeah, Tharva, go ahead.
Yeah, so what I think is we can relate this with maybe entropy. Like higher the entropy of the system, the lesser we can, like the less accurate value we
Correct.
can predict.
Correct.
The lower the entropy, the
Right.
better we can predict
So
it.
in
Entropy
normal
is related
images,
to moment, right? I mean,
randomness, the measure of
randomness, yeah.
randomness.
Yeah,
So
yeah.
what Tharva is trying to say that is the random dot you're putting there. Okay, he's trying to connect that with the idea of entropy. That the more the randomness is, the less accurate your estimation is going to be, right?
Yeah,
So
correct. Yeah.
it and since we the images that we have took, they have sort of a pattern, right? If I have this, I clicked a photo of myself, then somewhere here, if I deleted one pixel around that area, there are green pixels, right? So they follow a trend. It's not random that okay, that particular pixel had red values greater than the rest of the. It doesn't make sense like that. So yeah.
Maybe that's how we can maybe
No,
predict
this is
how
a
much we can.
this is a typical question anyone would have in mind. What if it's a random dot independent of whatever is there in the matrix? That is generally not the case, right? We are not generating a random image with random pixels. It has some pattern in it, pattern which is defined by the universe, which we don't know. We don't know exactly what that pattern is, but the patterns have correlations. That's what Nishan was trying to say. Right? The word correlation is a big rug under which we hide our innocent ignorance. Right? But then it is there. So what we do is we try to figure it out using simultaneous equations. The word simultaneous equation here means that you think that this is depending on the other columns. That's a very stupid assumption, but that's the only thing that we can make here. Given that we don't have any other information about the image, at least your algorithm doesn't have any other information about the image. Right? But as a human, you see, you can do that much better than the machine itself. On the cheek, if the pixel is missing, you know what would that pixel intensity will be. Right? Or on the shirt, if it's missing, you know exactly where it's missing. You see the neighborhood, you also know it's a shirt. You have a lot of details, but you cannot feed all those details for your algorithm. Of course, you can have a machine learning algorithm which will understand what you're wearing and all that. That's a different story altogether. But then given just the matrix, what is the entry there? Is simply asking the question of find the average of the neighboring pixels and go one step beyond, one more step beyond, one more step beyond, and super duper steps beyond the idea of average, which is weighted average of the columns and the rows as much as possible. More the merrier.
And so typically here the rows will be a lot larger than the columns. Typically in a real life, you may have 1,000 patients, but only 10 columns, right? So if that is the case, whether we are looking at a row picture or a column picture, so the complexity and the speed at which we will find the solution will be different. We may arrive at the same solution or same number, but if we look at the column, maybe we'll get the answer faster. If we look at the rows, we'll get it slower, right? Depending on how many, it's more about dimensions, right?
Yeah, but then at the end of the day, you're handling, the complexity seems to be the same. You're handling few columns, but they're from Rn where n is big.
Correct.
Or you handle many rows from Rm where m is very small.
Yeah,
एक जगह में many हुआ, in the other place you have less.
This is the
Right.
same question that I posed a couple of days back, sir. That is it better to deal with less number of vectors in higher dimension or more number of vectors in lower dimension?
It depends on what is your algorithm. Maybe your algorithm does not differentiate this. It sees it as an m cross n matrix. The simultaneous equation that you people are working on right now is very agnostic to whether you take the row picture or the column picture. It will innocently give you the answer based on the perpendicular distance from the point. Right? I mean, now connect the dots. Because we're doing least squares. The higher dimension, perpendicular distance. It doesn't make sense at all once you go beyond third dimension, but that's what is happening here.
Yeah, because we are taking each point as a tuple and then calculating it across.
So can you people figure out what the pixel value is and then compare and then see whether it is right or wrong? Use simple least squares now that I have told you how to do it. Right? All of you all are big brains. You should be able to collectively converge to the answer quickly. Atharva is there to code. Copilot is always there behind Atharva. Atharva is like Krishna Paramatma, Dashavatara of Krishna Paramatma.
No, he's
Yeah,
like,
I've been
what?
trying for like 20-25 minutes and I still couldn't find out. I was using same method.
No, least squares apply kar lo. Ax equals b. Least squares, you don't even have to specify the names. Just solve Ax equals b matrix. That's all.
Yeah, I was doing same thing, but I was getting some error in that. So I was
is
not
that
able to solve the
okay?
error.
Maybe Nishan, you want to try?
Yes, sir. I'll try, sir.
Yeah. So maybe you all can try the code parallelly on your machines. Maybe it's the Linux problem, installation problem.
See, in case of linear algebra, when the matrix is singular, we take something called a pseudo inverse, P inverse. So linear algebra P inverse. So if like
that's basically SVD. Yeah, that's basically pseudo inverse.
So if it is a 1000 cross 5, we take the missing J column to the end, then we can take only the partial matrix and then very quickly do the P inverse of X multiplied by Y to get the equation using NumPy.
Yeah. Actually, all these things happen in the background. One of the easiest way is simply solve AX equals B. That does it for you. But you can also find the A plus, whatever Davis Smith is suggesting as pseudo.
Yeah.
You are not audible, Chetan. So Atharva, if you can send me over that matrix.
Which one?
The image data.
Just a minute. I have put it on GitHub.
Sure. Can you also send me the commands you typed for, getting to that algorithm in Copilot? I'll just try to do the same.
Which one?
The Copilot commands, initial commands that you gave.
By the way, what is all your hunch? Do you think you'll get the accurate answer there or no?
We can get around the accurate answer, in my opinion, because what we are
What's the percentage error you are expecting?
Depends on the amount of data that we have. The greater the pixel.
Yeah, no, but take a rough guess if I ask you to gamble. 1% error, 2% error,
More than that.
Maybe even less.
10% error, less than 1%.
I guess it is
Yes, sir,
less than 1%, I guess.
Okay, let's see.
So how many records we have? 3,000 records, right? 3,000?
How much error did we get that day?
That's right,
whenever
David
you
Smith. We have around 3,000.
3,000
3,000
records.
cross 4,000.
That day we have around 609%
Right. So
more.
No. It was 150% exact.
No, for some entries it
152%.
was 609. I just calculated some
No,
random.
I was talking about like RMS of all the errors. That was like 152%.
See, if we apply stats for knowledge, any model with, if we take the total variance, you're trying to do a regression, total sum of squares. If you are able to explain 60-70%, you have a good model. So R square of 0.7 or whatever, right? So our error, my estimate is minimum 20-30%. Because it's a very diverse data. Unless the data is really neat and clean and homogeneous, then you'll get a nice, we'll see. It's going to be a lot of noise.
okay. Nishan, can you share your screen maybe?
Yeah.
Download some photo from say Unsplash or
I'll be dealing with the same photo as
Shutterstock.
Atharva was having.
Yeah, you can clone that repository. It has the same photo.
Sure.
Okay. Go to
Say this one, right?
Yeah, correct. Just fork it.
This is all we have to do, right?
Maybe give it give the prompt to the.
Copilot.
Mhm. Mhm.
Oh, by the way, I heard that Windows is given like by default Copilot that does like some
Yeah, that's
interesting stuff.
VS Code. VS Code has it. You have to add the.
No. I was talking
No,
about the
sir.
one in operating system.
Oh,
That's based on GPT-4. That's based on GPT-4. This is Git
Win-
Copilot is bit different.
Windows
Codex.
11.
Yeah,
Yeah, Windows 11.
This is Codex.
I'll have to see. I have Windows 11, but I haven't used it in few months.
GPT-4 is actually present in Edge as well.
Module not found. No module found named PIL. Sorry. From PRA. Okay. So I'll have to import PIL. Fine.
Pip install.
Can you do pip install PIL?
Okay.
Just do pip install PIL. It will automatically download.
I must try it on.
Yeah, pip space install PIL.
Capital P.
Capital P. Let it run. It's running.
Hmm. They're saying the no matching distribution found for
Is it a
PIL.
pack? Yeah, I don't know.
Update the pip. So do -m space pip install space. Yeah.
Yeah.
You have to give Python first.
Bharat is saying that do pip install pillow after this.
Yeah, it is Pillow.
Pip install. Afterwards, after upgrade PIP.
Yeah. After you upgrade it, do upgrade.
What should I write now?
Enter.
Okay.
I think you're missing it starts with a -m. You should give like Python, then space. Yeah, just add Python on the front, I believe. Yeah.
Yeah, it's doing it. Okay.
It's only upgrading the pip. We still have to.
So do pip install pillow afterwards. That will do it.
So a lot of people use pip3 also for Python 3, but it looks like
So what was the command I forgot?
With the algorithm
Pillow.
that we just discussed,
Do
is it
pip
possible
install
for us
pillow.
to like
Pip install pillow. No, not PIL, pillow. Pip install pillow. PILLOW.
Okay.
Do backspace. Pip. Yeah, backspace. No.
Small pillow.
It's yeah. I think it's case sensitive, if I'm not mistaken. Small.
Fine.
the algorithm that we discussed today, Is it possible for us to find out which pixel is missing using this algorithm?
No,
There you
we'll
go.
have to, for that, we'll have to know the position of that. So, okay, let me just stop the screen recording first.